Hello friends, in this video we are going to discuss a numerical 2 on the compensated semiconductor. So the numerical 2 is given by, here it is given that Nd is equals to 10 to the power 14 atoms per centimeter cube, and Nd means the donor concentration of the semiconductor. Similarly, here it is given the Na is equals to 5 into 10 to the power 13 atoms per centimeter cube, and this is Na, which will be equals to the acceptor impurity concentration. That means in this semiconductor both the donor and the acceptor impurity has been doped. So it will be a compensated semiconductor. Now from this data we can see that Nd value is greater than the Na value. So we can tell that it is a N-type compensated semiconductor. So it is also given the temperature is at 300 K, which is a room temperature, and the resistivity of the intrinsic material, that is rho I, is given by 60 ohm centimeter, and the applied electric voltage, that is mod of capital E, is given by 2 volt per centimeter, and also the Ni value is also given by 2.5 into 10 to the power 13 atoms per centimeter cube, and a ratio of the mobility of the holes and electrons is given mu p by mu n is equals to 1 by 2, and we have to calculate the conduction current density. So from the data of Nd and Na we have conclude that it is a N-type compensated semiconductor. So if it is a N-type compensated semiconductor, then the majority carrier concentration, and majority means it is a N-type, so the electrons, so majority carrier concentration will be given by N, that is equals to Nd minus Na divided by 2 plus root over Nd minus Na divided by 2 whole square plus Ni square. Now both the value of Nd and Na are given in the numericals, and Ni value is also given by this equation. So if I put the value of Nd, Na and Ni, then we can find the value of Nn. So it will come out as 6.03 into 10 to the power 13 per centimeter cube. Now in this way we have calculated the electron concentration in this N-type compensated semiconductor. Now let us calculate the minority carrier concentration, that is the hole concentration, using the mass action formula. So the majority minority carrier concentration of this N-type compensated semiconductor will be P suffix n, which will be given by the mass action formula, that is Ni square divided by Nn. We know the value of Ni, that is given in the problem, and Nn value we have derived. So after putting those value we will get 1.03 into 10 to the power 13 atoms per centimeter cube. So, this is the minority carrier concentration in the N-type compensated semiconductor. Now, the resistivity value of the material is given by 60 ohm centimeter. So, we can write rho I is equals to 60 ohm centimeter, and we know that the resistivity equation is given by 1 by Ni into Q into mu n plus mu p. So, Ni value is given, Q value is given, but a ratio of mu n and mu p is given. So, we will transfer this ratio value in that equation. So, from that we can say that mu p divided by mu n is given by half. So, we can write this equation in this form: Ni into Q into 3 of mu p. So, now from this equation we can write that mu p value will be equals to 1 by Ni into Q into 3 into rho I, and rho I value is given by this 60 ohm centimeter. So, we know the value of this Ni, Q and rho I. So, if we put all these values in this equation, then we can find that this mu p value will be 1388 centimeter square volt second. So, this is the mobility value of the holes. So, from this mobility value of the holes and using this equation, we can find the value of mobility for the electrons. So, mobility value for the electrons will be 2 into mu p, and this mu p value we have already derived this mu p value. This is 2 into 1388, that is 2776 centimeter square per volt second. Now, we have got the value of mu n and mu p. So, we can calculate the conduction current density. So, the conduction current density, we know the equation, it is given by N Q mu n plus P Q mu p, this is the sigma value, and into E according to the Ohm's law, because J equals to sigma into E. So, if we put all the values of N, Q, mu n, P, Q, mu p, all the values is known, and E value is also given. So, by putting all the values from the equations, we can find the value of J conduction as 0.058 ampere per centimeter square. So, this is the conduction current density value of the given N-type compensated semiconductor in the numerical. So, this is all about this numerical. Thank you.